Our next speaker is industry-recognized artificial intelligence and data scientist. Fortune and Time has defined her as one of the best European talents in human digital behavior. She's been to Oulu many times in the past. And today, she's back to give us her keynote speech on transformative forces of AI. Ladies and gentlemen, it's my pleasure to welcome Inma Martinez.
Hi, it's a real pleasure to be here because I was very lucky in 2004 when a venture capital firm in Helsinki asked me to be the CEO of an Oulu startup called Visual Radio. And I remember I came in June 2004 and had discussions with UTEL. We put the money in, and by October that year, I came for my first meeting my team, which was 5 people. And very young people. We grew in about almost 3 years to close to 50 people, and developing not just one software for all the Nokia handsets, but also software for all the radio stations in the world, and launching from Asia through Europe into the US, and eventually Nokia bought the company. So Oulu was my home, and it makes me so happy to be here. This is where my career really came to mean something very global to me. So I was asked to present a first slide that would represent me. And I chose this one because recently, because of the work that I do in AI and trying to understand how the human brain works so that I can develop much better deep learning, and my own career, I've discovered that really what I have always been is an explorer. And believe it or not, for the last year, I've been working with the European Space Agency, where everybody's an explorer, and really is what I feel defines myself. Explorers are people that go out there, whether you're an entrepreneur or you actually go into uncharted territories, and you conquer them and you develop them, and this is really what defines me. So one of the things that is happening to the world is that it's beginning to realize that not just AI, but a lot of digital forces are coming into place. It's cloud computing, high-performance computing, the processing power of machines, and everything is happening at the same time. And many governments and large corporations are trying to make sense of what's going to happen to their business, the famous disruption. So AI is seen as a negative force as opposed to a force for good. So to explain why AI is a force for good, the first thing you need to realize is that AI is the natural manifestation of our neoteny. And what is neoteny? Well, the thing that differentiates humans from the rest of the animals is that we have neoteny. Neoteny is very powerful curiosity. So when you talk to anthropologists and you talk about the hominids, Homo erectus, Homo sapiens, when did the Homo erectus left Africa and ended up all the way into Java? It's because he was curious. And he said, you know what? Let's just go out there. And out there meant all the way to the island of Java and China. Before we were intelligent, we were explorers. In fact, creativity, now that we can photograph the brain, is in our frontal cortex, in the same place where we decide we're going to move through a room. It's decided here. Creativity and movement, forward movement. So we then became explorers. And being an explorer means being brave, taking on the challenges, being very curious, asking questions, moving out of your comfort zone, which is what defines entrepreneurship. An entrepreneur is someone really comfortable with change and challenges. This is the nature of the business that you're trying to create. And when humankind left the jungle, we actually began to explore not just geographically, but also a new concept, better. Yeah, we invented things and then we started making them better. The famous innovation at the very beginning was quantitative, make it better. Maybe same thing, but better. Yeah? These guys are the Portuguese, not the Spaniard. And if you remember the story, when the Spaniards were bringing all the gold back to Spain, all the British pirates would wait for them as they were approaching Europe. And then they would ransack the ships and steal all the gold off to Queen Elizabeth. But not with these guys, because the Portuguese, which traditionally have been discovering many regions, Greenland, they built the better boats. And nobody could catch up with these guys. This is why you don't hear stories about British pirates ransacking Portuguese boats. They built the best boats, which is what makes you an agile company. You see the connection with the whole theory of entrepreneurship, the agile company, building better propositions. And today, and this is something I'm going to disclose to you all, we are building entire new sectors in space. Traditionally, the space industry has been about engineering, rockets, scientists, then telecommunication satellites for TV viewing, for broadcasting, for satellite navigation, all very telecoms. Well, as of 2020, we're going to start building a presence in space, first around the moon, but not because we want to put more telecom satellites, it's because we're going to be mining on the moon. We're going to be building vehicles that have to go on the moon. And the moon is a horrible place. It's not like a smooth, remember the astronauts flying? No. Landing on the moon is pandemonium. The terrain is really spiky and there's ravines and crates. The poor rovers on the moon can only function every 8 meters, and then they have to stop because of radiation and because of the 2 weeks of night on the moon. It is a hell. So we need mining companies to come to space. And we need engineering companies that build vehicles to come into space. And pretty much, very slowly, every sector is going to jump into this new realm. We are going into out-of-Earth orbit. Is one of the most challenges that governments are now realizing. And 2020 is just the takeoff. Can I just ask, out of curiosity, who has seen the SpaceX Falcon Heavy launches online? Okay, did you see the first one in 2017? Or the last one with the real cargo for the Arabsat? This is just the beginning. Pay attention. Start considering if you are in a sector that can have an expansion into space, because then the opportunities are there. So, what is happening is that science itself is also changing from what science used to be. Science, the birth of science, was a discipline that allowed you to make sense of the world, to actually understand the truth about reality. That was science. You went into investigating things. But with AI and with new technologies and this new society that we have built, in which we can create digital realities, we can use AI to create new molecules, etc., we are entering into a space in which the question is no more, can we do this? Honestly, we can do anything. I work at a big university in the UK called Imperial College. The stuff I see postdoctorate do blows my mind. The place where I work, Deep Science Ventures, is an accelerator for scientific projects. Literally, a scientist today can do anything. Anything. So if we can do anything, what is happening to science? And what is happening to science is that science is becoming, where is this thing? Alchemy. Remember the medieval men? If you take, low quality materials, we could potentially make gold. That is alchemy. That is what we're doing with AI. With AI, we're basically transforming realities. We do a lot of simulations. We do new molecules. That is the new science. The pretty much, not can we do something, but should we do it, and should that be for the benefit of society? So science is beginning to be very ethical. We're starting to question all of this technological development. Is that going to create value for society, or is it going to destroy it? So, molecules. I have mentored 2 projects in which new molecules were invented. One of them was a biodegradable industrial glue. You say the sentence, and 5 or 10 years ago, it would have been impossible to comprehend. An industrial glue is not toxic, it's actually biodegradable. The answer is yes. And how? Thanks to AI. We were doing constant simulations, simulating the building, the molecular structure of what we needed to create. So if we can do things like that, the natural thing is to create an artificial brain. AI is an evolution of our scientific muscle. Of course, we can build a super machine intelligent brain. The question is, what kind of a brain are we building? And AI is a very, very old industry. The first data analytics, which is the basis of statistics, come from the 1950s. This is when the machines began to achieve tasks computationally. And then in the 60s and the 70s, when scenario planning was used, again, it was used by governments, then moved into the military, and it moved into companies like Shell. The oil companies have the best scenario planning models still today. But something happened in the middle of the 1990s. Collaborative filtering. Anybody knows this algorithm, what it is? Is the famous people who bought that book also bought that book. That is a collaborative filtering algo. It's Amazon. Is the basis of personalization. This is when I built my first AI, exactly doing that. And now, obviously, automation. The machine can carry out tasks by itself without any human intervention. For example, at airports, the gate that is chosen for every aircraft is chosen by a software system that runs on artificial narrow intelligence. Imagine a human being trying to decide at Heathrow where all the planes are going when there is a takeoff and landing every 1 minute, 23 seconds. We will be creating horrible mistakes. Machines are very good when all we want from them is computational force brute. But as we progress, we're now using them to predict with predictive models. And eventually, some people begin to argue that machines in a not too distant future will have situational awareness. That is where the music stops and it begins to be a horror story. Why? Because if you want a machine to have situational awareness, it means the machine has deterministic learning, meaning it knows good and it knows bad. And by definition, good and bad are abstractions. The good for me maybe is your bad, and my definition of bad maybe is your definition of good. This is where everything collapses. And this is where many scientists like myself, for years we've been saying, no, that is wrong. We will never get to the singularity moment. Who has heard of the Singularity University? Okay. When these guys set up that university, we, the real AI people, were like, what? The singularity moment, meaning uploading our consciousness into a machine? On what drugs are these people? And finally, Wired magazine this month finally officially announced, actually that's never going to happen. Of course it's never going to happen. It's pure fantasy. But, it made them really famous. The truth about AI is that it's not about intelligence. The future that everybody wants is cognition. It's a huge difference, cognition and intelligence. Cognition is you really understand the subtext. You really have insight, not just intelligence. You know what's happening and what to do. That is cognition. This is what all the world and companies want. Cognition is the commodity of the future. Remember when in 1996, Garry Kasparov, who was the world chess champion, was challenged by IBM to play a game of chess with blue? How many people remember that? Right. He won. When you meet Garry Kasparov, and he does a lot of keynotes, he always says, but I won the first time. Yeah, it's true. Only people remember that he lost the next year. And he lost, and he explains it, because he made a mistake. And with a machine, if you make a mistake, the machine trolls you, literally like a panzer. There's no way that you're going to save yourself. The machine is faster. So he could not undo his mistake, and the next 6 games, the machine just won through and through. Now, is this a good thing for humanity? Who thinks it's a good thing that the machine won? And who thinks it's a bad thing? Right. Let me ask you something. Do you think that this beautiful biological brain was meant to do multiple calculations of tons of data per second? The answer is no. That's why it's great that the machine won, because it proves that machines are very useful for massively intense computational tasks. We don't want to do that in our heads. Thank God the machines are here to do that. Because do you think that the world of gymnastics was doomed when Nadia Comaneci got the perfect 10 in Montreal in the 70s? Well, what are you going to give the next gymnast, an 11? You see, we cannot create a society based on computation, because humans are non-computational beings. We are abstract beings. So we are beginning to see the end of the IQ society. What's your IQ? Are you a genius? That doesn't matter anymore. And we're moving towards an emotionally intelligent society where someone can make sense of both abstract and non-abstract, when someone can be creative, when someone can be non-computational and design amazing things. This is the value of the human thinking, emotionally connected, emotionally intelligent. Why do I want to have 145 IQ if literally I'm going to be using a computer for a lot of things? It's a waste of my intelligence. So, neurogenesis, our ability to create new thoughts and more creative connections in our brain synapses, which, by the way, happen until the day you die. Old people rejoice. You know, they say old people get... No. We continue regenerating our brain forever. It's fundamentally abstract. We are able to think in ways the machines cannot. And that is the value of humans in the future. So when you look at which will be the things that machines will do versus which are the things that we're much better prepared, there are clear cuts in the two. And this is a very, very good chart because this is what I spend hours in the lab working with cognitive neuroscientists. Are the brain algorithms better than the machines? Most of the time they are. But the best, and the one thing that machines will never achieve is tacit knowledge. And it's very simple to explain. Tacit knowledge is knowledge you accumulate over years of doing something to the best of your abilities until you kind of do it subconsciously. For example, do you think that Serena Williams is the best all-time tennis champion of the world because she trains 25 hours a day? No. It's because she has played hundreds of tournaments, and when she jumps on the court, even if her opponent is physically more able, she's going to win that match because she is tactical, because her brain is connected to almost doing things without thinking. That is tacit knowledge. Tacit knowledge is somebody that has worked for 25 years or 20 years in customer sales, and this person walks into a meeting, talks for 5 minutes to the client, and already knows if the client is going to buy the software or not. That's tacit knowledge. It cannot be put into words. I cannot ask this person, teach me how to be a salesperson like you. It's impossible. This is why it cannot be put into words, so it cannot be put into code, so I cannot teach the machine how to do it. That is the knowledge that humans will deploy. This is how you divide and conquer in the future of a company with automation and with human beings operating. And if you want to ask me, like, oh, but the professions of the future, are they all scientific? No. Look at this. Category flexibility, a very, very human ability. Yeah? Our ability to mix and match ways of classifying objects. Like, as soon as you see something, you see all the possibilities. And look at all the professions of the future where this particular ability, you need it almost every day. It goes from biochemists to nuclear engineers, to file clerks, food scientists, psychiatrists, all the way to landscape architects. It goes across everywhere. Scientists and people designing a garden or a park. This is how the human brain operates in the future. And many people feel that, but how come we're hearing this message now? And the answer is very clear. Cognitive neuroscience, meaning the science of how the brain works, is only 10 years old because for only 10 years we've been able to photograph the brain and what lights here and what lights there. Before we didn't. And this is why this is new knowledge that is beginning to cascade into the world. Now, what is deep learning? I'm sure you've heard deep learning. Well, rather than using mathematics to teach a machine how to predict something, with mathematical algorithms, which is very straightforward, you actually try to teach the machine to think like a human brain. A human brain works with neurons that when you learn something new, they fire and then they wire together and then a new thought is formed. This is the pictures that we take. And you do exactly the same with a neural network. You very slowly start teaching the program how things happen, what it should do, and then you start creating neural connections that go very, very, very deep. That's why it's called deep learning. But it's in a neural way how the machine works, not with math. Now, why is it so hard to make it work? Because the human brain is really a cosmos. It's so hard. I'll show you examples. First of all, deep learning is not code. You teach with reward functions. This is one of them. A reward function in which you say, and when you get to this point, that means the task is completed. This is the reward function that we use to tell a machine to stop. So you have your loss, eventually decays, and then it stops. So it will be used, for example, to teach a machine when it has to switch the engine off after parking, etc., etc., etc. Yeah, this is how we do it. With, like when you train a puppy and you give them a reward, was exactly. And when you do this, this is your reward. But what are we doing? We're also giving reward for exploration, meaning, okay, this is the way I want you to do it, but I'm going to allow you to think about a way that you think is possible. Yeah, so we build rewards for explorations. And that's when everybody's crashing. I'll show you a very popular example. Oh, where is this example? Remember the famous Facebook chats that were bargaining against each other, trying to sell to each other products, and eventually they invented a new language that was not even English, it was like gibberish? Reward for exploration, yeah, is very, very hard. So what is it that we control when we use AI? We, the people, decide the hypotheses, we decide the assumptions, we even decide the data sets that we're going to analyze. But AI is useful because we don't know what we don't know. And AI brings it on. AI is good for unknown unknowns. Did you remember this? This French AI team in Paris taught an AI program to paint in the style of the French Impressionists and then sold the paintings at auction at Christie's for $500,000. I think it looks horrible, but I don't think that people are going to stop painting in the world. So yeah, machines eventually learn. But you see, machines are very good at simulating being human, but they're not good at being human, yeah? What machines are good at is when we use them for massive computation. So I am working with a German car manufacturer in trying to create a new material with which to build a car that will be lighter, it will have better thermal dynamics, better crash dynamics. And we take tons and tons and tons of data that no human can calculate, and put them through this algorithm to actually see the car changing and where we need to put this or that. Those simulations is where AI comes and creates new realities, because humans can only see in 3 dimensions. Machines can see in multi-dimensions. So visualization of data is one of the greatest things that AI brings to us. New realities that we didn't even imagine they were possible. For example, in the world of pharma, the new formulas are being created with AI programs. It's called AI drug discovery. Because you're actually making them in a computer simulation, not in the real lab on a Petri dish, they're super cheap because they cost nothing. You're not using real materials or real lab time, and they are almost perfect. So they're faster, cheaper, you get them in the market much better, less prone to mistakes. AI is everywhere. Or this is how oil companies prospect for oil deposits. These visualizations are mind-boggling. I got this one from BP. It's just 3D, but you can reverse them, you can then bring them down. It's insane. These are petaflops of data. Every single mark is data, data, data. And thank God for visualization. So again, if it wasn't for AI and its ability to visualize in multi-dimensions, we would not be able to understand what to do. This is how AI is bringing value to companies. But the most important thing is that the concept of progress has also been disrupted. In the first 14 years of the 21st century, all of the patents and the inventions achieved in the 100 years of the 20th century were achieved. We actually went over the number. And what does that tell you? That life and progress are not quantifiable anymore, because if it's a numbers game, we already beat it. So what is progress today? It's about creating value. It's not about patents, it's not about how many, it's about radical value delivered. You know, if I am a company and I invent the cure for cancer and that's all I do, well, jolly good. Cure for cancer is the value of the one. So our progress is about delivering benefits to the world, not filing patents like in the old Silicon Valley days of the microchips. And how is the paradigm shifting? Very easy. Remember when we used to create innovation by reinventing and iterating. Not much difference between these two wheels, not much difference between these two wheels. And finally, when the rubber came into the tires world, yeah, fantastic. But have we done anything after this? No. No, right? All of this is 20th century all the way down to the caveman. Let me show you something from our century. This is a wheel that is both round and square. Yeah? You want to see it working? Right. Whoops. Why is it not working? Okay. Okay, somebody, how do I get this thing to work? Yeah, I'm double clicking, but woo! No. Oh, I need to show this. It's amazing. Why is it not working? But it's not with the... Okay. It's because it gets rid of stones. Because it was designed the way snakes and sharks move. So remember when we invented the wheel, well, now there's the wheel. This is the 21st century wheel. People think that things that were invented, they were done. No, we can go and totally create new worlds of invention. When this wheel was invented, these guys were trying to create a turbine and eventually realized that that was a better value on the ground to get rid of, obstacles. The square wheel is the disruption of the 21st century. So when companies have to embrace challenges, the first thing that happened to them is like, which are the challenges we need to embrace? Which hell do we pick up first? And what they don't realize is that sometimes the thing that seems like a challenge can be your attribute. An attribute in competitive advantage is something very particular in your circumstances that you can use as your advantage. For example, where you are based, or the language that you speak, etc. So the Atacama Desert, which is the driest desert in the world, nothing grows there, not even animals. I was there. At night, it looks like Burning Man. Hundreds of astrophysicists come out with their telescopes, and it looks like a super party. The driest place on Earth is the best place to take observatory photography. So that's how you turn an advantage out of something that looks something horrific. So think about how can you do that. Made in space is coming. These are nanocubes where blood samples and petri dish tests are being developed in zero microgravity. And one of the things that we've noticed is at zero gravity, molecules behave in very, very different ways. It's more controlled, you get the results faster, so eventually clinical trials will be made in space. Again, microgravity is really held to move around the International Space Station, but if you take samples, it's the best place for the samples to be developed. Again, attribute. Or, who knows this bike? The Brompton bike that can fold? Well, when this was one of my clients, I went to visit their factory in West London. And I asked the CEO, this is a private company. You have 200 people here, not even that. How can you compete against the Chinese folding bikes market? I mean, the Chinese are just going to take you over. And he said, no. I said, how many patents do you guys have? And he says, 0. 0. Because every piece of this bike is made to measure. They have spent 20, 25 years. The wheels are non-standard. All of the nuts and bolts they have designed. Literally every piece of the bike is bespoke. So to try to create an identical bike will take 20 years. It's mind-boggling. 0 patents. And do you think that Elon Musk basically got the cleverest engineers from NASA, and that's why the Falcon Heavy has 2 recoverable engines? The answer is no. They have recoverable engines because both SpaceX and Blue Origin from Jeff Bezos and every rocket launcher is a private company that has very little money, and they really need to recover all the equipment. So it's not about clever people, it's about economic needs, reimagining, or repurposing, okay? So we can send things into space with rockets, which is very costly and engineering-wise is very hard to lift off from the Earth. Well, there are some companies that are building space balloons. And once you go over the 85 kilometers and you actually see the Earth blue and the sky is black, yeah, you then launch anything you need to. So much less propulsion. The rocket can be any shape. It doesn't have to be like a pencil. There are a couple of 4 or 5 small startups building this principle. Again, it's about reimagining. This is the brilliance of the mind in the 21st century. Reimagining things, repurposing things. The challenger banks. Do you guys have challenger banks in Finland? Small startups that have created banking apps. Originally, in the UK, when they started to appear 2-3 years ago, people called them challenger banks. But now that everybody has one of those cards, you realize that they're not a bank. They are not about money. It's about data. It's not about the value of the deposits that the millennials put. Millennials apparently have no savings, so I don't know what deposits they're going to create for this thing to be a bank. It's a company that mines your data. They know which Starbucks you get the coffee from and where you buy your lunch and what you do with your money. Is about mining data. It's not about banking. So again, repurposing. And the future is not so much about robots. It's about human creativity. The creativity of humans creating the solutions to big problems. When the cars drive by themselves, we don't need traffic signals. There are already 13 cities in the world that have auctioned how to redesign Amsterdam, how to redesign Barcelona when the self-driven cars, okay? A robot is not going to do that. A robot is muscle, computational muscle. Creativity comes from the head of a person. Oxygen, and I've done many smart city projects, is the biggest problem of cities of the future, when 60% of the population by 2050 lives in an urban center. Japan has already begun to build big oxygen facilities in 3 of their top cities because they know that in 2050, 3 of their biggest cities are in the top 10. Oxygen is not about electric bikes, it's about oxygen. And third, but not least, mental health is the 21st century's cancer. Cancer is going to be cured. Mental health is the new massive disease that it needs to be tackled. Humans need to create solutions for the big problems of the future. And in AI, because AI comes to transform life, what is happening is that ethics are coming. The end of Facebook is coming near. Already in the US, there are calls for it to be broken down. The end of Google, because of algorithms out there on the internet are discriminating against people. They're taking advantage of your mental illnesses. They're creating profiles about you that you don't know. The internet that you see is not the internet that your dad sees. Why is that? Huh? algorithmic discrimination is one of the biggest legal cases that is coming after GDPR. It's not just about we hold data of people, it's what are we doing with the data, and are the things we do legal and proper and ethical. And when robots come to be with us, the robots are not going to look like Sophia, that horrible, horrible robot that has the Saudi Arabia passport. The robots will have a purpose that will not denigrate our humanity. And this is one of the trends that you see in robotics, because every technology will have to be human-centric, built for how a human needs to perceive reality and feel comfortable. So, thank you so much. Oh, are you launching that?
I'm already launching the catchbook. I hope the audience has some questions to Inma.
Or a comment. It doesn't have to be a question, it has to be, yes, please.
Can I shh?
So how are you going to teach AI a gut feeling?
They're trying. It's impossible. It's impossible. I didn't show it here, but humans have 3 brains, not 1. So the majority of the behavior and the way we think, it comes from chemicals. In the limbic system, which is inside our brain, is where the emotions are, is where the chemicals make us interpret things. And then we have an inherited brain that comes from the dinosaurs. This is why we can walk and do lots of things automatically. The machine is only computational. The machine is only cortex, force brute. So abstractionism, gut feeling, sense is biological. It's really, really, really impossible. Because you have to program it with math, which is a tool. So no, machines cannot have gut feelings. We don't want them to have gut feelings. It would be like bias, total bias.
Thank you.
Any comments? I don't see any movement. Oh, you have one? Okay, and then you.
Yeah, I can pass this shortly. What I had in mind is when you talk about the reward progress for machines or for programs, and is that how do you decide when something is good or bad, and then explorative? It's the explorative part that I was thinking about, that I'm not sure. How do you decide if something in terms of exploration is good or bad to a machine?
So you heard it here. Why every time that Facebook is asked about this algorithm that extracting, and they seem that there's nothing they can do? Because it's like, why is Alzheimer's not surgically removed? You don't know where the bias occurred in the neural network. You don't know where to cut. AI is not like looking for a bug in the code. So it's impossible. You have to control, Alt, delete the whole thing. That's why they're resisting. Every time that says, why don't you do something? It's because they cannot say, because we have to control, Alt, delete 10 years of developing AI within the system. That's why. So the best uses of AI is when you have tons of data that you cannot even process in a normal computer, and you need to put it through something that needs to visualize. It's computational force brute. When you start teaching machines to take decisions, for example, why did that Uber run over the lady in California, yeah? Have you seen the picture of the woman crossing the road? So there is an old lady that at 1 in the morning decides to go buy food in the supermarket. And she goes with a bike and a basket, And then when she goes back home, decides to cross over a 6-lane highway with her bike. And that's the image that you see of the Uber approaching, and you see 2 legs with the bike. And of course, the Uber just went through. Why? Because the people programming that Uber had never shown an image of a bike with a person walking next to it crossing a road. So the Uber didn't recognize it. This is how machines work. You have to show them, this is it, move to the next. And that's why the Uber didn't stop, because humans are not supposed to cross the road at night with a bike next to them through the lanes. Exactly. So, but a human would have stopped, because we have a cerebellum that comes from when we were dinosaurs. Is hot? That's the part of the brain that we have that comes to us for free because we are biological. We don't need to program it. When you see a baby walking at 12, 13 months, yeah, it's extraordinary. Have you seen robots walking? How do they walk? Yeah? 20 years of robotics, Boston Dynamics, and the robots, they still walk like robots because they don't have millenniums of years that come from dinosaurs walking. We do. That's why we move elegantly. It's all an interaction that is extremely biological within us. Okay, so you have a question?
Thank you very much. And thanks for a very interesting and positive speech and talk. It was actually because I've been thinking about the point that you made about the Singularity event or Singularity University, also what they were striving for. This is the first time that I hear that it is completely impossible to reach that level. Could you maybe comment on that?
Okay, so I'll explain how it works, which they never explain how it works. Right. So their positioning is, in the future, if we take slides of our neocortex, because remember what I said, we develop our own synapses. Yeah, if I open your head, I will see all the connections and I will see your thoughts. Yeah, I will see them. Okay, so they will take slices of the brain and then build an identical neural network in a machine, identical to your synapses, slide by slide, like ch-ch-ch. And therefore, when both of them are identical, your consciousness will be uploaded into this identical part of you. At this point, you have to say, sorry, I don't like the movie Inma. Like, nice try. Maybe Terminator. It's virtually impossible. Uploading consciousness, that means that the thoughts have to be coded into physical programmable parts. Don't you find that this is now where the drugs are beginning to crash down? The drugs they take? It's like everybody in the AI community, and I live in a university building AI with Nobel Prizes, when we heard about that, we were like, who are these people? And now, finally, they're admitting that obviously that is actually something very unlikely to happen. Yeah, thank you. It took you 5 years. But that is the reality. So consciousness is chemical, is emotional. People say, what kind of brain dogs and cats and mammals have? And it's pretty much limbic, chemical, cerebellum, and a tiny cortex. Because, you know, they're smart. Dogs are smart. They can learn, yeah? But it's purely emotional. So do animals have feelings? The answer is yes. That's all they have. They have a huge limbic system. Now, we are the intelligent ones because we develop a massive brain, much bigger than anything else out there in nature. Our computational brain, the one that learns new things. But that's it. That's it. That's why machines will not have emotions or gut feelings. They just do what you program them to do. And then they can predict really well because it's pure mathematics. pure math is prediction. I used to work in a big bank doing quant analysis. Math is, you can do lots of things with it. But creative processes, how Werner Panton goes to a factory where they make helmets, and he comes back home and says, I'm going to make a chair. Those connections only humans do. Because remember, category flexibility. Where he sees a helmet, he also sees a chair. That's the genius of Picasso, yeah? Machines don't do that.
Thank you, Inma. Will you be with us later
I will
tonight?
be. I look forward to the air guitar. Oh, yes. I am here for that.
Okay, thank you. So you can have a chat and continue the discussion
Thank
and
you.
ask more questions. Thank you very much,
Thanks so
Inma.
much. Thank you.